Question 10, 2021, water flowing into and being removed from a tank. The volume of water in the tank is measured on a daily basis using this function. And V of t is greater than or equal to 0. We can't have a negative time. Find the value of t when the tank empties. So this is an inverted quadratic. There's going to be a tiny bit of it to the left that wouldn't be acceptable. And we're looking for this time here. So when is this quadratic equal to 0? 60 plus 41t minus 3t squared equal to 0. So 3t squared minus 41t minus 60 equal to 0. Does this factorize? Well, we'll always check first. It may be the quadratic formula. They haven't given you the quadratic formula in this exam yet. Well, we can actually 15 fourths. That'll get me to 45, and that'll get me back to 41. So it does. And we're going to have minus 45 plus 4. So t is equal to negative 4 over 3, which will be in here, which it can't be. Or our solution t is equal to 15. You could plug that back in if you wanted to check. Find the rate. So immediately we're thinking dv dt once we see the rate, and they're telling us when t is equal to 5, so a simple dv dt when t is 5. So dv dt is equal to, the 60's gone, 41 minus 2 3's are 6, 41 minus 6t when t is 5 is 41 minus 6 times 5, which is equal to 30, and we're dealing in liters per day. Liters per day. That's part 2. Part 3. Question said 41 minus 30. 41 minus 30, which is equal to 11 liters a day. If you got to this point and you hadn't fallen asleep, 11 is the answer there. Part 3. Find the value of t when the volume of the water is a max. Have to find when dv dt is equal to 0 here. When is dv dt equal to 0? 41 minus 6t is equal to 0. 6t is equal to 41. T is equal to 41 over 6. Fairly easy. Is this ominous of what's to come? Part 4. Part 4, find the max volume. So that's V of t. And we know that we're actually looking for V of 41 over 6. V of t is 60 plus 41t minus 3t squared. So we have 60 plus 41 times 41 over 6 minus 3 times 41 over 6 to be squared. Now always double check this in your calculator that you get the same answer twice. And I have checked it twice. I'm getting 200.08. And to the nearest litre, this tank has 200 litres in it. Nice easy parts 1 to 4. Let's look at the next section. So we're given a huge amount of writing, you can see, and then we're just asked to show that something satisfies this condition and show something else. So we're dealing with a function here, the increase in the radius of a tree. And it's 1.5 plus the sine of pi t over 4. So I'm just going to jump down here and look at that. 1.5 plus the sine of pi t over 4. 4 or 5? Was it 5? I think 5 pi t over 5. Pi t over 5. Okay, 1.5 plus the sine of pi t over 5. So this is a periodic function. So 1.5 plus 1 is its max value, and 1.5 minus 1 is its minimum value. So 2.5 and 0.5 is the range of increase in the radius of the tree here. So let's have a graph. Let's see a graph of it. So we take this line as 1.5. Write it to the side of it. That line is 1.5. It's a sine function, so we're going to go up. We're going to go down, and the increase over time is going to look like this. So if we take this as time, and this is my centimeter increase of the radius over time. So let's extend our graph. So this minimum point here we said is 0.5, and the maximum up here 2.5. So my minimum increase, and I have my max increase. What else can we tell from here? We've got these points here. Can we work these out? Normally we can see these 4 points easily enough. We can get to these two in a second. Let's have a look at when this function is equal to 0, pi t over 5. When is pi t over 5 equal? Well, when is the sine of pi t over 5 equal? Sine of pi t over 5 equal to 0. Well, the sine of 0 is equal to 0, so that's this one here. And the sine, you guys already know, the sine of 180 is equal to 0. So pi t over 5 in terms of pi would have to be equal to pi. So therefore t over 5 will be equal to 1, so t will be 5 here. So that's the next point we have here, 5. So this one will be 10, this one will be 7.5, and this one will be 2.5. Just let's confirm the 10. 2 pi over c is equal to the period, and c in this case, you can see up here what's in front of t is pi over 5. So that's c, so 2 pi divided by pi over 5 is equal to 2 pi times 5 over pi, which is equal to, when you cancel your pi's, 10, which is what we said here. This 10 is one full period for this function. So that's what we're dealing with here with this increase. This is the increase in the radius of a tree year on year from year 0 to year 10. And actually, what else can we see here? This may help us later in the question. All of these increases over time from year 0 to 5 are above 1.5. They go from 1.5, they climb, they're still above 1.5 coming down here until they get back to 1.5, and now the increases become less than 1.5. So what can we say over this 10-year period? All these less than 1.5s are going to cancel out with all these more than 1.5s. They're going to be identical because of the symmetry of the graph. So over a 10-year period, over 10 years, 1.5 by 10 is 15 centimeters, is going to be the growth rate of the radius of this tree over a 10-year period, 15 centimeters. Let's come back to that in a minute. Okay, what have we got here? We've got all this writing that kind of explains it. I'm sure you've read all this and been maybe slightly confused at the beginning and possibly not attempted this question in the exam. Okay, let's look at question 1. In order for the model to be reasonable, it must satisfy a number of conditions. One condition is written below. The radius of the tree is increasing year on year. Show that RT satisfies this condition. Well, we've drawn a graph of it already, because that's what your teacher would have told you to do with these functions. And we can see here from our graph, so you'd write into your answer here, from the graph we can see the range of increase. We have this here that will explain it. The range of increase, put this up into part 1. Show your range is between 0.5 and 2.5, and you've got part 1 covered. Show that the increase in year 6 is less than the increase in year 5, and explain what this means in the context of the growth of a tree. So we have to show, and we have to tell what the context is. So we can explain that from our graph too. So show C graph, and then maybe we'll change color just to make it jump out a little bit. We'll do a crazy pink. So C graph, here's year 5. So I5 is equal to 1.5. I6 somewhere along here. I6 is equal to, I've worked it out, I got I6, it's 1.5 minus 0.58. sorry, minus 0.58, which is equal to 0.92. You'd write I6 is equal to 0.92. And then I think I kind of said earlier, in years 1 to 5, the growth rate is above 1.5. So the radius increases more in the first 5 years than it does in the second 5 years between year 5 and 10. Then between year 10 and 15, again, the radius is going to have an increase that's going to be more rapid than between years 15 to 20. So that could be the context of this question, that the radius grows at a different rate, and the rate in year 6 is less than the rate in year 5, as is the rate between year 6 and year 10. That would explain part 2. Part 3. So 2 identical trees are growing in a forest. At the beginning of year 1, a tree was cut down and a section of its trunk in the shape of a cylinder of radius 10, standard length h. So we have a trunk cut down, 10 is my radius at the end of year 1. So that's R0. R0 is equal to 10 here, which we're told here. Now find R2, the radius of the second tree, 2 identical trees, so this is still growing. So let's have a look at R1. R1 is equal to R0 plus I1. So we need, that's going to be 10 plus the increase in year 1. And this goes back to our original formula, that's 1.5 plus the sine of pi t over 4 over 5, so that's just pi over 5. So that's R1. R2 is going to be this R1 above, which is going to be 11.5 to 10.5 and the 10 and the 1.5 plus the sine of pi over 5. And then it's going to be plus the increase in year 2, I2, which is going to be 1.5 plus the sine of 2 pi t over 5, 2 pi over 5. So that's going to give me 13 plus the sine of pi over 5 plus the sine of 2 pi over 5. Is that what we were asked to show? We have a plus the sine of b pi over 5. Okay, so a is equal to 13, b is equal to 1, and c is equal to 2. 3 solutions here. And then finally, if you haven't lost the will to live with the leaving cert, at t is equal to 10, second tree was also cut down. Now t is equal to 10 is going to bring us back to our graph. A section of its trunk in the shape of a cylinder of radius 10, standard length h, was also sent to a sawmill. So we've already seen the radius after 10 years. It's going to be equal to 1.5 by 10. The increase is going to be 15 centimeters. It was 10, so it's going to be 25. So we have the original. So what do we have? We have the first trunk from above. My sketch, we had a radius of 10, and then we have the same height of this one. It's just a standard size block they're sending. The second one is this guy here with a radius of 25, and we're asked something in relation to their volumes. V2 is equal to KV1. Well, the volume pi r squared h is that one, and this one is pi by r squared by h, and that's equal to k. We're told V2 is equal to k times the volume of 1. So we need to put a k here. The pi's cancel and the h cancel. So I'm left with 100k to 625. So k looks like it's equal to 6.25 in this question. Question 10.